Welcome to Mickey Study Circle channel. In this video, we shall see how to solve the given numerical using the merchant circle analysis. Coming to the problem statement. The following data was obtained from an orthogonal cutting test. Rake angle is 20 degrees, depth of cut is 6 mm, feed rate is 0.25 mm per revolution. The chip length before cutting is 29.4 mm, chip length after cutting is 12.9 mm, vertical cutting force is 1050 Newton and the horizontal cutting force is 630 Newton. Using the merchant circle analysis, we need to calculate the chip thickness ratio, shear plane angle, magnitude of the resultant force, and the friction angle. So with this data, let us see how to determine the given parameters. So before we solve, let us make a list of the given parameters. So here, first, the value of the rake angle, which is given by alpha, is equal to 20 degrees. And then we have got the depth of cut represented by the letter D is equal to 6 mm. And also the feed is given by 0.25 mm per revolution. And next we have got the chip length. So the chip length before cutting is equal to 29.4 mm and the length of the chip after cutting is 12.9 mm, where LC is the length of the chip after cutting. And next we have got the vertical cutting force. So the vertical cutting force here is the thrust force. So Ft is equal to 1050 newtons. And also the horizontal component of the cutting force is Fc, which is given as 630 newtons. So now these are the parameters that we need to determine. So first let us calculate what is the chip thickness ratio. So we do know that the chip thickness ratio R is given in terms of the length of the chip as the ratio of LC by L, where LC is the length of the chip after cutting and L is the length of the chip before cutting. So substituting the values, we have got 12.9 divided by 29.4. So on substitution, we are going to get the value of R as 0.439. So this is the value of the chip thickness ratio. That is the first parameter. The second parameter is the shear plane angle. And we do know that the shear plane angle is represented by the Greek letter phi. And the mathematical model is given by phi is equal to tan inverse of 1 minus, okay, r into cos alpha divided by 1 minus r sin alpha, where r is the cutting ratio and alpha is the orthogonal rake angle that is given to us. So upon substitution, let us see what is the value of phi. So we have got tan inverse of the value of r to be considered as 0.439 into cos 20 degrees divided by 1 minus 0.439 into sine 20 degrees. So upon substitution and calculation, we do get the value of phi as 25.89 degrees. So this is the value of the shear plane angle. The next parameter is the magnitude of the resultant force. So we can calculate the magnitude of the resulting force as the square root of Ft square plus Fc square. That is the summation of the squares of the two cutting forces and also under root. So the value of R is given by under root of the value of Ft is 1050. So 1050 square plus the cutting force is 630. So the value of the resultant force upon substitution will be equal to 1224.5 Newton. Next parameter to be calculated is the friction angle. So the friction angle is given by the Greek letter beta, which is equal to tan inverse of F by N. That is the frictional force by the normal to the frictional force. So here we need to compute the frictional force first. So the frictional force F is given by the mathematical model Fc into sine alpha plus Ft into cos alpha. So we get F is equal to, upon substitution of Fc and Ft values and also the alpha values, we are going to get the value of the friction force as 1202.15 Newton. So this is also one of the parameter to be determined. So we can just combine this to be friction angle and the friction force. And then we have got the normal to this friction force, which is given by the mathematical model Fc cos alpha minus Ft sin alpha. So upon substitution of the values of Fc and Ft, we are going to get the value of the normal to the friction force as 232.88 newtons. So this is the magnitude of the normal to the friction force. So the ratio of this and the tan inverse of the ratio is going to give us the value of the beta angle. So tan inverse of the ratio of the friction force, that is 1202.15 divided by 232.88 is going to give the value of the friction angle, which is equal to 79 degrees approximately. So with this, we complete the solution to determine all the parameters that is given in the problem statement. Thank you all for watching the video.